All right. So I'm back taking another look at the Bazel source code. Last time I ended kind of abruptly because I had people coming over. So sorry about that. I'm back now where I was when I left off, which is that I'm looking at the blaze module.java file. And I think we mostly milked this file. I think we mostly milked this file for everything that we could get out of it. The takeaway here is that this is a Blaze module is a type of module that you can define that has hooks into various parts of the Bazel or Blaze, as the source code calls it, workflow, the various processes that it does. And this seems to be a pretty key file. So if you want to know more about that, you can go back and look at the old video, which is on YouTube. Okay, so I had opened up a bunch of tabs last time, and I just kept the browser window open. So this is where this is the path that we had laid out for ourselves during the last stream. So now I'm looking at memory pressure module. And I guess looking at this, I'm mainly curious to see how they detect memory pressure and possibly what Bazel is going to do about it when it detects memory pressure. So we have a public final class, a memory pressure module, and it's going to extend Blaze module, which is the file that we just looked at. Let me increase the font size for readability of the video. And it's going to override a bunch of these methods. In fact, all it's going to do is override methods. We have workspace init, which actually, let me open up the Blaze module and find out when workspace init is called. I assume it's called when the workspace is initialized. Called when Bazel initializes a new workspace. This is only called after server init, and only if the server initialization was successful. Modules can override this method to affect how the workspace is configured. Okay, so I tend to think of Bazel as having only one workspace, but I think that you can have multiple workspaces on the same server. I don't know. Maybe that's something we can look up on the internet. Can Bazel have multiple workspaces? For most Bazel projects, I strongly recommend using a single Bazel workspace per source code repository. Yep. Unfortunately, workspace files are not recursive, so transitive dependencies do not get pulled in automatically. It is a common pattern to pull in the dependencies of your dependencies using a macro, like go rules dependencies. Okay, so each repo has a workspace. In fact, that might be what defines a repo for Bazel. So, okay, so workspaces, packages, and targets. A workspace is a directory tree on your file system that contains the source files for the software you want to build. Each workspace has a text file named workspace. Directories containing a file called workspace are considered the root of a workspace. Therefore, Bazel ignores any directory trees in a workspace rooted by a subdirectory containing a workspace file, as they form another workspace. Okay. So code is organized into repositories. The directory containing the workspace file is the root of the main repository, also called @ with no identifier after the @. Other external repositories are defined in the workspace file using the workspace rules, or generated from modules and extensions in the Bazel mod system. Okay, so the repo you're building is your workspace. And then what happens is you have dependencies, and those dependencies have their own workspaces. And that's what a workspace is. Okay, so we're going to call on workspace init. So for each workspace, for your main workspace and also for the workspaces of your dependencies, if you're going to load, memory pressure module.java, it's going to create a retained heap limiter and I'm not sure what that is. And it's going to call runtime get bug reporter, which I assume is there to report bugs if you have heap problems, and a memory pressure listener, which is going to have the memory pressure listener is going to essentially have a pointer to the retained heap limiter, and we're going to record both the retained heap limiter and the memory pressure listener as what I don't know what you call them in Java, members, I guess, of this class. Okay, and then before each command, we are going to set event bus to whatever the environment's event bus is. We're going to get options for the memory pressure option limiter. And we're going to create a high watermark limiter using the get Skyframe executor, a get syscall cache, and a Skyframe high watermark memory threshold, which we pull out of options. And then we're going to set those options on our retained heap limiter. And then we're going to register the high watermark limiter on the event, I guess, via the event bus. And then after each command, we're going to set the event bus to null, which I will assume just clears the event bus. And then get command options is going to return an immutable list of memory pressure options.class. Okay, so that's all straightforward. I don't know what a Skyframe executor is or what these things are. So I'm going to actually pull this out in its own tab and take maybe a closer look at whatever retained heap limiter is and memory pressure listener, because I think that that's where the work is done, right? So let's see if Google will, if GitHub will let us search for these things. No. Maybe Google will let us search for them. Retained heap limiter. Maybe cite GitHub. Can I restrict the site to the Bazel repo? No. Well, I mean, I can, but it doesn't do what I want. Okay. What if I just do add Bazel to the search? All right. Nothing. Okay, so we must import it from somewhere, right? So let's see. We have Blaze directories, high watermark limiter, and options base. What do you think? Maybe it's in the high watermark limiter file. So where is that? Lib Skyframe. Okay, so it's looking Skyframe. High watermark limiter Java. So do we have any heap? What was it? Heap listener? Okay, where were we? Retained heap limiter. So where is this thing? Retained heap limiter. Let's see. Do we have a memory pressure listener? No, we do not. So where are these defined? Okay. Blaze directories analysis. Maybe they're just in the same package. Maybe they're in the runtime package. Here we go. Yeah. All right, so here's the retained heap limiter, and then what was the other one? Memory pressure or something? Memory pressure listener. I think I may have opened these in another tab, actually. Okay, so here's the retained heap limiter. It monitors the size of the retained heap and exit promptly if it grows too large. Specifically, checks the size of the tenured space after each major garbage collection. If it exceeds memory pressure options, I guess, more eagerly threshold, call system hash GC to trigger a stop the world collection. Okay, so this just listens to see, we check the size of the tenured space after each major garbage collection. If it exceeds some threshold you set, we're going to just call the garbage collector to trigger a stop the world collection. Okay, so this is, I guess you would consider this part of garbage collection, but it's not part of the, like Java has its own garbage collection, right? So this is somehow doing additional work, I would guess. I don't know much about Java's garbage collector, so maybe if someone is an expert in the JVM, or then they would know more than I would. Okay, we've got a thread safety annotation. It can only be called on the logical main Bazel thread. And we call set options abrupt. We can create an abrupt exit exception. We can handle a memory pressure event. If throwing .get, so I guess this is detecting whether we're throwing then we'll do nothing if a crash is already in progress. Otherwise, we're going to check if heap limiter triggered garbage collection by doing, whatever this stuff is, and log some stuff. And then getting memory pressure options. The threshold is equal to 100, which is maybe a percent. Then we're going to return, which case is inactive. And then we've got this get tenured space used bytes times 100L. I don't know what L is. Is that long? Maybe. I'm going to guess that's long. I'm going to guess that this is a long. We're multiplying it by a long and dividing it and then casting it to an int. And I think that this probably is a percentage because we're getting whatever this percentage is. I mean, it could be something else, but since we're doing what looks like a rational number and casting it to an int, my guess is that this is functionally just throwing away the decimal places of a percentage, which is being recorded as an integer, and that's what's going on. Not positive, but that's kind of my guess. Okay, and then we're just looking at more garbage collection stuff. Okay, so this is this looks, not surprising. Create from beans, GC beans. I don't really know what a Java bean is. I guess this is probably Java bean related. I don't know what else a bean would be, but that's okay. And this is, we've got some function, find tenured collector beans. That's kind of a funny name. I'm imagining some sort of bean collector or a collector bean that's tenured, maybe in the academic sense if it's never going to lose its job. I don't know what the tenured space is, but perhaps this is some way of having like a unit of tenancy. What if I just look for tenure? What if I look? I can't do maybe tenured space. Nothing. So let's try Google. Tenured space, optimize, yes, must include tenured. So is tenured space a JVM thing? Let's try that. Maybe. Let's see if I can make it include my search terms. Okay, so the memory tab lets you choose between Eden space, survivor space, tenured, gen, code cache. Okay, so heap memory is the runtime data area from which the Java JVM allocates memory for all classes, instances, and arrays. The heap may be of a fixed or variable size. The garbage collector is an automatic memory management system that reclaims heap memory for objects. Eden space is the pool from which memory is initially allocated for most objects. Survivor space is the pool containing objects that have survived the garbage collection of the Eden space. And tenured generation, or old gen, is the pool containing objects that have existed for some time in the survivor space. Okay, so this is a generational garbage collection thingamajig, and it seems like tenured is maybe the oldest generation. So these are like the veterans of the object army that have survived most of the battles in the war. Now, I don't know. I thought I had more tabs open than this. Did I just close a tab? I didn't mean to. Can I open an old window? Hey, look at that. Yeah, I must have closed. Okay, so this is Server Builder. I don't think this is the window I was looking at. Okay, we've got Skyframe. We've got main, master. Okay, cool. So let's go back to whatever this window is. This is in lib. Okay, this is Blaze module where we were before. All right, let's take a look at Server Builder. So this is a builder class to create a Blaze runtime instance. This class is part of the module API, which allows modules to affect how the server is initialized. Okay, so this is still part of modules stuff. And it's a builder class to create a Blaze runtime instance. So this is, I guess, the part of the code where when you define a module that configures how the server is initialized, this is possibly the class, the builder class that actually does the building up of the server using those options. So I'm guessing we're going to see a lot of the builder pattern. Server builder is just a public class that does nothing, I guess. We've got an environment factory, get invocation policy, which calls out the invocation policy builder. Oh, okay. Oh, I see. Here's the real class. Server builder. We've got a query environment factory, which I assume is going to build query environments. And I know what a query is. I guess a query environment is like the context maybe in which a query is executed. We've got an invocation policy builder, some commands. Immutable list.builder are going to be build Blaze commands, builder of Blaze command commands. We've got info items. I'm not sure what that is. Query functions, which are, I'm not sure. I'm not sure if it's the function that ultimately executes the query, and query output formatters. Environment extensions, build event artifact uploader factories, and I'm build event artifact. So if this were called a build artifact uploader, then I would guess that was something that uploaded build artifacts. But since it's a build event artifact uploader, then it seems like it should upload build events. But I don't know what a build event is. So I guess we'll have to stay tuned to figure out what's up with that. And then we've just got a bunch of getters and add invocation policy, set query. So we've got setters, some stuff to add stuff, and this seems to be the builder pattern because we're going to add something or other, and we're going to return a server builder, namely this, so we can just keep calling .add foo or set foo in a chain, and it's going to keep returning these server builders. And this is just classic builder pattern. Okay. So this is, I guess, there's not a lot going on here. It's just like a bundle of things that actually do the work. Is my sense of this file. All right, what do we got here? A workspace builder. And we've got the Skyframe executor factory again. This is the builder class to create a Blaze workspace instance. This class is part of the module API, which allows modules to affect how the workspace is initialized. Cool. So this is kind of the same thing, except instead of the server, we're dealing with initializing the workspace. Now I'm noticing that something's gone wrong with my webcam. So why don't I see if I can fix that? Hang on. Can I pause? I don't think I can pause. Give me a moment. Okay. That's back. All right, so we've got this Skyframe executor still. I still don't remember what Skyframe is, so I'm going to look this up in a minute just to make sure that I'm not missing an essential part of how Bazel works. We've got this syscall cache initial capacity thing. I'm not sure what a syscall cache is. I assume it's some sort of cache of syscalls. I guess you're caching the results of syscalls so you don't have to make as many. So, so how are we setting it? We've got a runtime max memory, and we're going to shift it by 23. Okay, let's read the comment. The initial capacity here translates into the size of an array in concurrent hash map. So oversizing by n results in memory usage of 8n bytes. So the maximum wasted memory here is 1 divided by 2 to the 20 of heap, or 10K on a 10 gigabyte heap, which would start with about 1,280 capacity caches. Okay, so I'm not sure what 23 is. This is, I think maybe this is the same as we're right shifting. So is this dividing by 2 to the 23rd? Or is there a decimal place thing where we're really dividing by 2 to the 20th? I'm not sure. That's not hard to figure out, but I'll just live with my confusion for now. And then we're going to check if scaled memory is bigger than the max integer value, then something's bad. And we're going to send a bug report. And then we're going to set scaled memory to 1024. Else if scaled memory is, I'm not sure why they set it to 1024 rather than some other value. And else if scaled memory is less than or equal to 0, then we're going to, if Bazel's running in less than 8 megs of memory, very impressive. We're going to set scaled memory to 32. Otherwise, we're just going to cast it to whatever we got and cast it to an int. Okay. So I'm not sure how to understand why they are doing what they are doing, but I think the answer is that they've tested this on the Google fleet, and this seems to be the right thing. Okay, and then we've got this Blaze workspace build function. And if we don't have a syscall cache, we're going to create one, set initial capacity to whatever this is. I think this is the function we just looked at. Okay. And then we're going to have a Skyframe executor. And that's going to take a file system, some directories, an action key context, workspace status, some Sky function stuff. Okay, and we're going to return a new Blaze workspace that's going to just contain like pointers to all these things. And then we should have just a bunch of builder pattern stuff at the end. Okay. So let's take a look at Skyframe. At least to have a sense of what sort of thing it is. It's a parallel evaluation and incrementality model of Bazel. The data model consists of the following items: sky value, also called nodes. Sky values are immutable objects that contain all the data built over the course of the build and the inputs of the build. Examples are input files, output files, targets, and configured targets. So we're building a giant graph, and the nodes of this graph are the input and output, the targets, and the configured targets, which I guess are kind of target. A sky key is a short immutable name to reference a sky value, for example, file contents :temp foo or package :foo. So this is kind of like a labeling of the nodes. A sky function builds nodes based on their keys and dependent nodes. So given a key, which is a name for a node, we are going to build the node and its dependent nodes. I don't know what build means in this context, but I'm going to guess that it means like build in the sense of build the source code. Well, builds nodes, or maybe it just means assembles the graph. I don't know. Okay. A node graph, which is a data structure containing the dependency relationship between nodes. Okay, so I guess sky value is not, I think I was maybe thinking of sky value as the graph, but sky value is just the collection of nodes. And then we have like names for the nodes, and then we have functions that build nodes, and then we have the actual graph, I guess. And Skyframe is the code name for the incremental evaluation framework Bazel is based on. Okay, so let's at least scan through this. Evaluation. A build consists of evaluating the node that represents the build request. This is the state we are striving for, but there is a lot of legacy code in the way. First, its sky function is found and called with the key of the top-level sky key. The function then requests the evaluation of the nodes it needs to evaluate the top-level node, which in turn results in other function invocations, and so until the leaf nodes are reached. Until the leaf nodes are reached. Okay. Finally, we end up with the value of the top-level sky value, some side effects, and a directed acyclic graph of the dependencies between the nodes that were involved in the build. Okay. Incrementality. Since functions can only access input data by depending on other nodes, Bazel can build up a complete data flow graph from the input files to the output files, and use this information to only rebuild those nodes that actually need to be rebuilt. The reverse transitive closure of the set of changed input files. All right. Incremental linking and compilation, and mapping to Bazel concepts. All right, so I'll take a closer look at this later, but maybe just to orient myself and anyone else, it seems like what's going on is we've looked at GCC, we've looked at LLVM in other videos, and did we look at something else that had, we looked at GHC, the Haskell compiler. And in each of those compilers, you have kind of the same problem, which is that you have a graph that can be large, and you need to essentially run graph algorithms over this graph structure, and you want this process to be efficient. So in GCC, they have, I think, maybe 2 or 3 intermediate representations, like Gimple is one. There's another one that's, I think, starts with an R, but I forget the name of. And they have these different representations because, if I remember correctly, they kind of make it easier to do different sorts of algorithms on those representations. In LLVM, we had just the single, the lower level virtual machine model that created like a control flow graph. And I think the idea of LLVM is just to get that model really tight, and then the process of writing passes over that graph is made a little bit nicer. And then in GHC, the Haskell compiler, I don't remember looking a lot at what was going on with the control flow graph, but it did more or less the same thing. They built up a graph and then ran various passes over it, like optimization passes and converting to C++ or converting from C++ to assembly or WebAssembly or whatever. And so Skyframe seems to be doing the same thing, except instead of compiling an individual piece of source code, my understanding is that what Skyframe is doing is it's doing this same sort of activity, but like one layer of abstraction higher, or in the sense that it's building a whole repository, or at least it's dealing with a whole repository, and it's figuring out the software dependencies and the data dependencies, like which file contains which piece of software, and it's building a kind of control flow graph there. And in general, this graph might be too large for a single computer, I think, and so there's probably some distributed processing sort of stuff involved. And then Skyframe seems to be the model for trying to come up with a system where it's building these control flow graphs, and it's general enough to efficiently compute various algorithms over these graphs, and also allowing the Bazel team to extend and add new features that utilize this underlying structure. And so, if I'm understanding correctly, Bazel is doing this at the level of the source code repository. And then when it's building individual files, like when you're building like main.cc inside your repository, Bazel's calling out to your compiler, which might be GCC or LLVM, and LLVM is building its own control flow graph at like the source code level, where the graph kind of consists of symbols of functions that call each other, rather than the symbols or nodes being files that depend on each other. So I think that's going on. This is just me kind of like shooting from the hip. I don't really know. This is my first time looking at the Skyframe doc, but that's what I'm going to assume, that it's kind of doing the same sort of control graph stuff that we see in the compilers, but it's doing it at the level of the repository itself. Okay. So now we are in action.java. Okay, so an action represents a function from artifacts to artifacts. So it's like a transformation of an artifact executed as an atomic build step. Examples include compilation of a single C++ source file or linking a single library. Okay, so artifact must be pretty general, because compilation of a C++ source file is going to produce a compiled binary, or the linking of a single library. So I guess this is just build artifacts. Okay, so an action chomps on like a source and produces built stuff, but it can also do other stuff. That's how I'll think about it. Let's see. All subclasses of action need to follow a strict set of invariants to ensure correctness on incremental builds. In our experience, getting this wrong is a lot more expensive than any benefits it might entail. So all must follow a strict set of invariants to ensure correctness on incremental builds. All right. So what is this sentence about getting things wrong? Like, what is it kind of like modifying? I think what it's modifying is strict set of invariants. So like you might have the question, like, why are the invariants so strict? Why can't I do this or that? That seems like it should, maybe Bazel should allow me to do this. And what they're saying is that like, it's more expensive. I think that what they're saying is that it's more expensive to have like a loosey-goosey approach with lots of like nice to have features. The cost of that doesn't outweigh the benefits. Did my internet just drop? I think I'm okay. So the cost is the strictness. So like, Bazel forces you to do things in a specific way, and it can be kind of verbose. And what they're saying is that, like, at least in our experience, meaning Google. So when Google is building a giant mono repo, the cost of having all of the invariants be really spelled out and thought through is more than pays for the benefits of like having source code builds that are reproducible, that you can optimize heavily, and that sort of thing. So we've got some spawn action stuff. Use spawn action or file write action where possible, and avoid writing a new custom subclass. Okay, that's a good idea. So it seems like most things are either a spawn action or a file write action. And I'm going to go ahead and guess that spawn means we're going to spawn a new thread or something like that, so that we can do parallel processing. Okay, so here are the most important requirements. Actions must generally be immutable. We currently make an exception for C++, and that has been a constant source of correctness issues. There are still ongoing incremental correctness issues for C++ compilations, despite several rounds of fixes, and even though this is the oldest part of the code base. All right, so C++ gets special cased. Why? Probably because C++ is close to the metal. So at Google, there's Go and there's Java and Python, but there's still a whole lot of C++. And the things that really need to be fast are written in C++. I think I spent maybe 90% of my time there writing C++ rather than other languages that, if I remember correctly, Bazel kind of, before Bazel, I think there was just like GCC make files or something along those lines, which is total chaos. And there may be exceptions for C++ just because key pieces of infrastructure may have used make files in a certain way that don't quite fit into Bazel. I don't know. I'm just guessing. Actions should be as lazy as possible. Storing full lists of inputs or full command lines in every action generally results in quadratic memory consumption. Okay. Use nested set for inputs and custom command line for command lines where possible to share as much data between the different actions and their owning configured targets. Okay, so we don't want quadratic memory consumption, but we do want to be lazy. And by lazy, it means like I'm assuming it means lazy in the same sense that that something like Haskell is lazy, where instead of when it asks for a computation, instead of just having instead of doing the computation as soon as we know it's requested, we record like a string. Like we record like the request for the computation. Just like when you go to a restaurant, you request a hamburger, and that request goes in written form to the kitchen until the hamburger is produced. So it's kind of like if you need 1,000 hamburgers, instead of making like one at a time, make the hamburger as soon as the order gets in. First, they're going to accumulate all of the orders to see how many they need, and that'll say like how, and then only kind of when they're being this analogy doesn't quite work out, but anyway, accumulate the orders and then execute them as needed rather than executing them right away. And then it's saying, so we want to be lazy in that sense, kind of the same sense as Haskell, but we don't want to store all of the inputs naively in a naive way, because that's going to result in large memory consumption. So instead, we have these nested sets and custom command line thingies that are going to share as much data between the different actions and their owning configured targets. I don't know what that means, but I assume it means that if two things like use the same action or command line option or whatever, that they essentially point to the same configuration stuff in memory rather than having a different memory allotment for each action. However, actions must not reference configured targets or rule contexts themselves. Only reference the necessary underlying artifacts or strings, preferably as nested sets. Bazel may attempt to garbage collect configured targets and rule contexts before execution to keep memory consumption down, and referencing them prevents that. So actions shouldn't reference configured targets or rule contexts themselves. Only reference the necessary underlying artifacts or strings. Okay, so I'm not sure how to kind of interpret this, but I think what it's saying is like, or rule contexts. I forget exactly what a configured target is. Is it just a generated target? Let's find out what a configured target is. Okay. So it's from a general rule, maybe? Configured target. A set of configuration values that match this rule. The rule inherits the configuration of the configured target that references it. Is it just a target that's gone through configuration? So configurations, I think, are used to like programmatically choose options, right? Starlar configurations, Bazel's API for customizing how your project builds. You can define custom flags. You can define transitions to configured dependencies in different configurations than their parents, such as compilation mode optimized or setting a different CPU. And you can bake better defaults into rules, such as automatically building my Android app with a specified SDK. Okay, so I think that what this is saying is that like just depend, configured targets in rule contexts are like nodes in this graph. Don't depend on the nodes directly. The nodes get kind of processed into artifacts or strings, and use those so that you don't hold a reference to the targets, and we can garbage collect them. I think, maybe. And we want to avoid anonymous inner classes. Okay. Correct cache key computation in get key is critical for the correctness of incremental builds. You may be tempted to intentionally exclude data from the cache key, but be aware that every time we've done that, it later resulted in expensive debugging sessions and bug fixes. So I'm guessing if you implement a class, you define the cache key, which is kind of like maybe like hash in the Java world. You decide which information from your class, like which variables get put into a key, and you maybe somehow serialize it by creating a giant string that represents your class. And they're saying, make sure that you include all of the stuff in that string, because if you don't, and you intentionally exclude something because maybe you think it's clever or it's too expensive to compute, then you're entering a world of pain, I think is what it's saying. As much as possible, make the cache key computation obvious. Fully hash every field except input contents, but including input and output names if they appear in the command line in the class, and avoid referencing anything that isn't needed for action execution, such as build configuration value objects or even fragments thereof. Okay, so more stuff about advice about how to compute cache keys. Add test coverage for the cache key computation to generate as many combinations, and use action tester to generate as many combinations of field values as possible. So this is maybe a little bit like fuzzing or automatic testing, it sounds like. So you want to add test coverage and generate a bunch of different things so that you know in testing what the behavior of your thingamajig is when you add different values. These constraints are not easily enforced or tested for, so carefully check all changes to action subclasses. Okay, and so where even are we? We're in action.java. So we're going to define the public interface action. We've got prepare, which prepares for executing this action. So that's like a call, it's kind of like a workflow function that's called. Execute executes the action. The method unconditionally does the work of the action, although it may delegate some of that work to action context instances obtained from the action execution context, which may in turn perform caching at smaller granularity than the entire action. Okay. The framework guarantees that all declared inputs have already been successfully created. The output directory for each file in getOutputs has already been created. This method is only called by at most one thread at a time, but subsequent calls may be made from different threads. For shared actions, at most one instance is executed per build. All right, cool. Execute unconditionally returns true if and only if the action must be executed regardless of its current state. Is volatile returns true if it's ever possible that execute unconditionally could evaluate to true during the lifetime of this instance. False otherwise. Okay, let's take another look at execute unconditionally. It said if and only if the action must be executed regardless of its current state. Default implementation can be overridden by some actions that might be executed unconditionally under certain circumstances. For example, if caching of test results is not requested, this method could be used to force test execution even if all dependencies are up to date. Okay, if caching of test results is not requested. Note, it is very important not to abuse this method since it completely overrides dependency checking. Any use of this method must be carefully reviewed and proved to be necessary. Note that the definition of is volatile depends on the definition of this method, so be sure to consider both methods together when making changes. Okay, got it. So it sounds like execute unconditionally basically does a lot more work, and they're saying be really sure if you want to do that. And not only does it do more work, it bypasses like all of the dependency magic. So that's bad. For reasons other than just doing more work. Discover inputs. It's a method used to find inputs before execution for an action that discovers inputs. Okay. Prepare input discovery. These are functions, I guess, you override or implement. I'm not sure I don't remember what the Java language is when you have a, what's it called, an interface. Okay. Shows output unconditionally, get extra action info. What is extra action info? Call it at execution time to extract information from this action into a protocol buffer to be used by extra action rules. So I guess there are rules that you can request extra action to be done on the output. So I suppose maybe that's user configurable in the build file or something. Get effective environment is some get environment stuff. All right. Action cache aware action. So this is now that we know what an action is, it's relatively easy to guess what this might be. There's some cache of actions, and the cache aware, some actions will be aware of that cache and some won't, and these is just a guess. Action analysis metadata. An analysis phase interface for an action or action-like object. What's an action-like object? Containing only side effect-free query methods for information needed during action analysis. So you can run queries, but they can't have side effects. So they can't, create files or whatever. Okay. We've got stuff like get owner, get mnemonic, pretty print, describe. Okay, that seems pretty harmless. Here's the action graph. How big is it? Small, tiny. The action graph is an interface that returns the action that, when executed, gives rise to this file. Get generating action. I see. That gives rise to this file. But how does a file know what action gives rise to it? If this artifact is a source file, null is returned. All right, that's straightforward. We don't try to return a no-op action because that would require blah, 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 blah. It's also possible to derive for derived artifacts to have null generating actions when these actions are unknown. Okay, so seems like some people may not know their action, and that's fine. But if you do, you can implement this function. All right, what else? What else? Here's actions.java. Isn't that what I just looked at? Or did I look at action singular? So actions is what? We've got a logger of some sort. We've got a path escaper. Private actions. Depends on build ID. Determines whether the given action needs to depend on the build ID. I'm not sure what a build ID is, but maybe it's like a UUID for the build. Can be shared. Checks if two actions are equivalent. This method exists to support sharing actions between configured targets for cases where there is no canonical target that could own the action. In the action graph construction, this case shows up as two actions generating the same output file. I wonder if they have to generate it in the same way. Okay, so how do we know if it can be shared? Well, if A says it's shareable, that's good. Does B have to say it's shareable? Okay, so A and B both say they're shareable. All right, step one. And the mnemonics are equal. I'm not sure what a mnemonic is, but maybe it's some sort of name or something. And check that they're both actions. That's good. Actually, I'm curious why you don't check that they're not actions first. That's just an optimization question, but it seems like maybe it's uncommon to call it on non-actions. And I think for optimization, what do you want? You want to execute as quickly. You want to exit as quickly as possible. So maybe like is shareable for A and B are quick to evaluate and are called frequently, so they go to the top or something. I don't know. Actually, just for funsies, let's blame this file and see maybe if the last few commits have been optimizations. Update from Google. Okay. So this is just pushed. Yes, understandably, this is pushed from the Google internal code base. Improve performance of artifact conflict detection. Yep, exactly. Exactly what I was guessing. I'm not often right, but when I am, it feels kind of nice. All right. Use the action count to pre-size data structures that grow with the number of outputs. Short circuit output registration when detecting that actions can be shared. There's no need to check for each output since shareable actions must have identical outputs. And some other stuff. Okay. And, okay, so what was there before? Okay, before there was, okay, so is shareable was higher up. I mean, it was exactly where it is now. Mnemonic is the same as it is now. And really, they just kind of formatted it. But instead of having ifs, it's got ands, which I guess does a short circuit if any of the conditions is false. Is that what it said? Something about short circuits. Okay, cool. And I'm sure if we went even further back, we could detect, what is the evolution of this method and how do they optimize it. But it does seem like they're concerned about optimization. Can I just hit back? Okay. All right, so that's can be shared. There's some a more involved can be shared log thing. Artifacts equal without owner. So this is kind of like bookkeeping about actions. This is a long method name. Look at that. Assign owners and maybe filter shared actions and throw if conflict. So it checks actions for conflicts and sets each artifact's generating action key. Conflicts can happen in two ways, blah, blah, blah. Okay, cool. You could have this comparator that you can use to compare things. It looks at the file path, execution path, some lengths of strings, and then I'm guessing it. Okay, so just checking. It takes the min of them, and it's looking at characters. Is this just like a fast string comparison method? I don't know. All right, well, whatever. That's a hey, you know what? Let's blame again. Let's play the blame game. Now, where's that long method name? Somewhere. I think it's called math.min. Okay. Improve performance of artifact conflict resolution. Okay, yeah. Great. That's unblame. Normal view. Okay. Keep deterministic ordering of bad actions. What function are we in? Find artifact prefix conflicts. So it's looking for prefix conflicts. And okay, we've got some escaped path stuff. All right. Base rule classes. So what is a base rule class? Rule class definitions used by almost every rule. Well, if it's used by almost every rule, I guess we should take a look. So it's visible for serialization. I don't know what autocodec is, but something serialization related, I assume. Let's see. Get default resolved with raw attributes. Label lists late bound default. What does this do? Implement is the implementation for the action listener attribute. Action listeners are special rules. They tell the build system to add extra actions to existing rules. As such, they need an edge to every configured target with the limitation that they only run on the target configuration and should not operate on action listeners and extra actions themselves to avoid cycles. Okay. Test-based rule. Test-based rule implements rule definition, a base rule for all tests. So what is this going to do? Okay. You know what? I hear somebody playing some music upstairs. So I think I'm going to stop here and then take a kind of resume where I left off either tomorrow or next time I get a chance to do one of these. Thanks.